Hello, Sci Fam. It's your boy Nickel here, and I want to teach you all about how to get set up for the Vinegar loves baking soda science experiment. Now, in order to begin, I've got my materials here. You can see I've got a lot of stuff. I've got my scale, and I took it out of the plastic containers here, and you can see it's still saying hello. So in order to get this scale to work, I have to set it down and let it chill, turn it on and off again, and then it will register that it's nice and relaxed, it's chilled out, and now it's at 0.00 G. G is grams. When we measure things with a scale, we're measuring the mass of them, and the unit we use is grams. Now I've also got my Erlenmeyer flask. I've got a graduated cylinder that is empty. I've got a balloon. I've got an infrared heat gun, the baking soda, and you can go ahead and get one of these containers of vinegar from me. I will get that for you so you can add it to, so you can conduct the experiment. And then you also need a funnel. Yes, this scrap piece of paper is a funnel. So if you're looking for a funnel, go over to my desk, grab a piece of paper, a half piece of paper, rip it in half if you have to, and we'll use this as our funnel. Okay. So before we begin anything, we need to make sure that we are practicing safety protocols. So go ahead and get yourself some goggles over at the sink. Okay, so once you have your science notebook page taped in, let's take a look. Vinegar loves baking soda. The reason we're doing this experiment is because I want you guys to really get a sense of, our common name is vinegar, but what's the chemical name and the chemical formula for vinegar? Same thing with baking soda. Again, we're starting to learn chemistry, chemical names, chemical formulas. But this experiment, really, what I want you guys to be focusing on is proving the law of conservation of mass, and also making observations that a chemical reaction actually has occurred. So you can see in question number 2 and 3 there, it's really helping you focus on those two things. Understanding and viewing the law of conservation of mass, as well as recording and observing the indicators that a chemical reaction has occurred. And if you need some help with that, double check your science notebook note pages because you just took notes about all of that stuff there. Okay, so to begin here, one thing that it asks you to do is that you need to use a funnel to place 3 grams of baking soda into this balloon. Now, it's tough to just take a spoon and get baking soda into this balloon and weigh it and back and forth. So the way that I want you guys to do this is to put the balloon away for a second. Get this shallow plastic piece and place it on top of your scale. Now, I'm gonna take my piece of paper, I'm gonna fold it in half, make a nice crease, unfold it, and place it here in this plastic tray. Now this is registering about 22.14 grams because grams is the mass, it's the unit we use for mass. So 22.16 grams, well guess what, that doesn't matter. I don't want to weigh this stuff. This stuff is just helping me collect my baking soda and I want to measure the mass of my baking soda. So I'm gonna hit the T to tell the scale, this is my new 0. Now I'm gonna take my spoon and I'm going to scoop about a half of a spoonful of baking soda, just a little at a time, until I have about 3 grams. So I'm at 1.8, 2.89, 3.06. That's really close to 3. So I'm just gonna leave that. That's close enough. If you have 3.0 something, that's good. Okay, 3 grams need to go into the balloon. So in order to transport your baking soda into the balloon, you're gonna take your piece of paper and you're gonna keep it folded. You want that foldedness to really help you out, and this is gonna become your funnel. You're then going to slowly put it into your balloon, and you can kind of tap it on the side to get it to go into the balloon. I'm not adding mine to the balloon right now because I'm not conducting the experiment. You will be doing that. All right, well, as we continue to set up our experiment, some other things that we're gonna need to do is to use a graduated cylinder to measure 20 milliliters of vinegar. So this is a graduated cylinder. A graduated cylinder measures volume. So as you can see here, this one has a maximum of 25 ml is the max of the volume of a liquid it can contain and measure. ml is milliliters, so the unit for volume, or how much vinegar we have, is milliliters, You can see lowercase m, capital L. Now we only need 20 milliliters, and so I'm gonna measure that out now. Let me show you how to use a graduated cylinder. So you can get one of these beakers of vinegar from me so that you can get your 20 milliliters overall. You also are gonna need a pipette because it's gonna help you be really precise here in your measurements. So I'm gonna start by pouring some vinegar into my graduated cylinder. Get as close as I can, but I went over just by a scoosh, just a little bit. So that's where my pipette comes in. The pipette can be used really effectively to draw some of that vinegar out until I get exactly 20 milliliters. Or if you don't have quite enough and you're just really, really close, you can add a little bit of vinegar using the pipette until you have exactly the amount that you need. You can then transfer that into your beaker. Okay, again, I'm not doing the experiment, you are. So the last thing, or I shouldn't say that because I have two more things I'd like to show you. One is that this will have vinegar in it and this will have baking soda in it. When you attach your balloon to the beaker, it's important that you don't get the baking soda into the vinegar yet. So be very careful as you stretch the balloon around the top of the Erlenmeyer flask. Now, what we want to make is we want to make a system that no gases can escape our beaker and our balloon system. We also don't want any gases or anything to be able to enter there. We want to make sure it's just vinegar and baking soda and then the air that we trap as well in here. And that's it. We don't want anything else to enter or exit. That's called a closed system. Nothing can enter, nothing can exit. So once you get the balloon on the Erlenmeyer flask, you're going to want to put a piece of tape around the neck of the Erlenmeyer flask. Just one piece is fine. You don't need much, but it'll just help secure the balloon to the flask and also stop any gases from trying to enter or exit that are not allowed. So once that's all together, then you're going to place it on the scale. And the reason it's on the scale is because we're trying to observe the law of conservation of mass. So we need to weigh it before, during, and after the reaction. Now, another thing we want to observe while all of this is going on is if there's a temperature change occurring. And so you're going to use the infrared heat gun here, and you're going to measure the temperature. Now, you can't measure the temperature of the glass because the glass actually reflects heat. So my heat is reflected off of this glass. Yep, I can almost see my reflection in the glass. That's pretty cool. But what you want to measure is actually the temperature of the balloon. So if you put the crosshairs on the balloon, it'll give you much better data because you can actually measure the temperature change of the balloon as the reaction occurs. So you're going to want to keep an eye on and observe the temperature of the balloon before, during, and after the reaction so you can witness and see if any change happens. Keep a close eye, see what you see. So that is how you're going to get set up for this experiment. Again, you need to have eye protection on, and when you're all done, you can throw away your balloons, you can turn on the sink, dump your solution down the sink drain, wash out your beaker, make sure there's no little chunky pieces of sodium bicarbonate, aka baking soda, in the beaker. Make sure that it's all gone so that the next people don't have a reaction happen when they add their vinegar to this beaker. Don't contaminate it. All right, you guys all rock. I will see you in the classroom. Let's do this.